You got the point?
Yes, sir.
Yes. Sorry, CRO is basically an oscilloscope. So oscilloscope, what is that oscilloscope? That oscilloscope is uh, actually sort of wave, that is a display, you can say, right? That display is that display is used to show the wave shape. When we consider the wave shape, that means if we will have a dial on that, that dial will have some sort of method to read. So this has all these uh, four points, positions, right? And on all these points or positions, we have, this is its y-axis, this is its x-axis, this is its y-axis, this is x-axis, negative and negative and positive. Now, actually, as I told you, that CRO is to show the wave shape. So wave reader, we simply call it that it is what? It is a wave reader, right? It reads the wave shape. You got the point? It reads the wave and it shows the wave shape. Shows wave shape. Lulu is, are you in the class? And Noor? Okay. So when I say this, let's say आपको एक wave दिखा रहा हूं मैं. This is a wave, and in that wave, definitely, what are the properties of a wave? Can anybody tell me? Yes.
Sir, again, what were you asking?
Yes, wave can have time period, right? Wave can have frequency, wave can have amplitude, wave can have amplitude, right? So these 3 points are very important. And one more thing, wave can have wavelength. Is it? So if it is measuring all these, definitely there will be uncertainty in that. So what is time period, by the way? Yes, Misha, can you tell me? What is time period?
Time taken for one
Time
wave.
taken for one complete wave. Okay? Time taken for one complete wave. Okay? And that is represented by capital T. I will show you on the graph. Then I will be talking about the CRO. What is frequency then? Huma, are you there?
Yes,
Huma, what is frequency?
like number of waves in a second per
Okay.
second.
So number of waves completed per second, per unit time, you can say. So actually, the unit of time period is second, whereas unit of frequency is hertz. This is one upon time period. So I have a relationship between frequency and time period. That is, frequency is equal to one upon time period. Our time period is equal to one upon frequency. So sorry, frequency is what? Frequency is one upon time period. Frequency is one upon time period, or vice versa. Or you can say time period is equal to one upon frequency. Now, moving on, what is amplitude, by the way? Uh,
Maximum
yes,
displacement.
Mariam.
Oh, sorry.
Okay, no issue, no issue. Is Mariam in the class?
Yes, sir.
Mariam, batao, what is amplitude?
Amplitude is the height of the wave.
Yes, height of the wave above the mean position or above the equilibrium position, right? Height of wave above its above mean position or equilibrium position. Okay, right. So when we have the voltage signal, actually there is an important thing here. Amplitude can be your displacement, amplitude can be your sorry, voltages, amplitude can be your current, etc., etc. So I can simply say that amplitude is nothing but what? Amplitude is your uh, x, amplitude can be your volt, v, amplitude can be your current, right? V stands for voltages, I stands for current. Is it clear to all of you? R, power, pressure, intensity, something like that. Okay, is it clear to everyone? And what is
Yes.
wavelength? Lulu, are you there?
Yes, sir.
Yeah, what is wavelength?
A wavelength is the distance between the crest and the crest, or a trail and the trail.
Okay, yes, the length of one wave are simply saying the distance between two consecutive crests, right? Distance between two consecutive peaks are crests, right? Now, I will be moving onward. So this was basic concept. Everyone knows this thing. It means that once I'm using a wave CRO oscilloscope, if this x-axis is there, so this x-axis gives you some values and y-axis gives you different values. So let me explain it to you. Beta ji, y-axis gives you this all what I'm gonna write here. Y-axis gives you voltages, y-axis gives you current, okay, voltage, distance or displacement, current, amplitude, etc. etc. Okay,
Okay.
okay. But x-axis gives you rest all of the things. X-axis gives you uh, time period, frequency, and wavelength. You got the point, everyone?
Yes, sir.
Okay. So if I say that this can be calculated from the CRO, so you people must know how to read the CRO. Okay, ji? I'm not going to discuss about the internal structure of the CRO, but the main topic what I'm going to discuss with you, that is how to read oscilloscope or CRO. Misha, I will need your help. In CRO, as I told you, x axis पे क्या होता है Misha?
The time, frequency, and wavelength.
Yes, time period. This is the fundamental thing. Time period, right? R wavelength. Then we will be talking about frequency afterwards. Okay, and wavelength, and this all is basically done in this way. For example, if I just consider this wave, is there anything mentioned on the x-axis, time period, or y-axis? Nothing is there. That is why your CRO has two controls, X control and Y control, right? So there are two controls of CRO, and you must know about those two controls. These are actually the controls of CRO. Sorry, control of X axis. I am just writing in bits. So control of X axis is basically time based setting. What is the X axis control? That is your time based setting. Got the point? Time based setting. Please recall this, time based setting. Now, time based setting means that, this is actually CRO is nothing but the grid. So, time based setting is the value of one unit, one division, or one square, or 1 centimeter along x-axis. This is very important to know. That is why I'm explaining it in detail. So, for example, that is, if time-based setting is given to you, time-based setting is, let's say this is the time-based setting. So all the times I will not write time-based setting. I will just put equal to and I will make you clear. For example, time-based setting is 0.5 seconds per division. So what does it mean? What does it mean? That one division along x-axis equals to how much?
0.5.
Yes, 0.5 seconds. Well done. So it means that if 1 second, oh yeah, one division along x-axis is equal to 0.5 seconds. This way. So one, two, three, four. So basically, on x-axis, one division is indicating, and this is scale actually. This is equal to 0.5 seconds. You got it? Then if time-based setting is equals to 20 milliseconds per division or per centimeter, so what does it mean? That this same distance is now indicating 20 milliseconds. Is this very clear to everyone?
Yes, sir.
Okay, oscilloscope. Okay, so this oscilloscope basically tells us this way. So इसका मतलब ये हुआ कि if I have a wave and that wave comprises of two and two four divisions, right? If this wave is just consisting of four divisions, what will be its time period? Uh, can anybody tell me?
Two.
What will be its time period? Its
2
time
seconds.
period, yes, its time period will be equals to, very simple concept, but this is very interesting. You will say that number of divisions occupied by one wave, okay, occupied by one wave into time based setting. Simple, okay? Time based setting. Is this very clear to everyone?
Yes, sir.
Okay, now, for example, for this one, I'm going to figure out the time period. So, time period is equals to, what is the number of divisions occupied by this wave? One division, right? One division, two divisions, three divisions, four divisions. So, I will simply write there are four divisions. And what is the time based setting? For example, if I'm setting or if I'm using this 0.5, so it will be 0.5 seconds. So that is 2 second is the time period. You got the point?
Yes, sir.
But if the time based setting is changed now and you have the same wave, and for that time based setting you have 20 milliseconds for one division, so what will be the time period now? 80 millisecond. You got this point? So same wave is showing different things. Yes. Is it clear to everyone?
Yes.
But is it
Yes,
clear to
sir.
everyone? Same wave, yani same amount of wave is showing you two different time periods. So that is why I was saying that once we are talking about oscilloscope, we must know about its, you know, how to read it. So once we are going to read it, or if we are going to now how to read it, it will be quite easy for me. Just let me add a page which has which has these grids, right? One more page with the grids. Okay, now because I'm teaching you CRO, so I will need the grids. That is why I have just selected the page with the grid lines. Okay, ji? Is there any confusion in this one?
नहीं
Yes?
सर.
No, sir.
नहीं है कोई confusion? Okay, सबको clear है?
जी.
Okay, now moving onward, I will be talking about the frequency. So, for example, what was the frequency of that wave? The wave uh, which you have just drawn ahead. Let's say मैं इसको अगर देख लेता हूँ. Let's say this is the CRO dial. Okay, on this CRO dial, this is one division, right? This is your one division. This is one division. No need to uh, claim it that this is not one division. Actually, this is one division. So for this, I can give you one more wave just for practice, and you people are requested to calculate the frequency of the wave. Right? This is a different concept. Sorry. This is not a symmetric wave. Okay. Yani this wave has different positions. Let's say these are the positions of this wave. Now, for time based setting is equals to 60 milliseconds per division. Calculate time period and calculate frequency. So what will we do right here? It's quite interesting wave because this wave is not symmetric wave. So for example, this wave has started right from here. So once it is starting from here, now you have different uh, starting and ending point. So for all type of these waves, what will you do? You will write this complete formula for your convenience, that time period equals to time base setting into number of divisions on grid divided by number of complete waves. There is an there is this formula is really helpful, and this is not discussed anywhere. But I have solved one MCQ. Yani that MCQ was very tricky MCQ. Uh, Yes, Lulu, if you remember, there was an MCQ in the past papers that there is a coil and it is connected to a rotator, and there were 3,000 rotations per second, and you were supposed to show how many number of waves will appear in 10 centimeter dial,
Yes, sir.
right? So these type of questions are basically asked here. Perfect. Then number of complete waves can be written here. So please remember this thing, that this is the masterpiece of formula. It will help you to calculate everything you need. Everything. Time period कितना है? I have to calculate time period. What is time based setting? 60 milliseconds for one division. How many number of divisions are there on the grid? Now I will say, for example, I do not know about this part of the wave. So I will start right from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I can say that if I just complete here approximately, then how many waves are there? One division, it is starting from 0. 1, 2, 3, 4, 5, 6, 7, and 8 divisions are there. How many divisions are there? 8 divisions in the grid. And what is the number of complete waves in this? If I say that one wave is starting from this and one wave, then it is two waves, 2.5 wave, and this is 2 point yani 75 waves. Yani I can say that how many complete waves? One complete wave, is it? One complete wave, two complete waves, 2.5, and then 1/4. So 2.5 plus 1/4, yani 2.75 waves are there. 2.75 waves are there. So this is the most critical wave where you don't have any accurate value. So 2.75 waves I have on this grid. So what will I do? I will just calculate the length of one wave. Actually, I calculated the length of one wave. Now, just calculate this all. Okay, wait for 1 minute. 8 divisions are there. And what are the total number of waves? 7.5, because it will not have any unit because this is a number. So this division and this division will go on, and your result will be 60 times 60 into 10 is power minus 3 into 8 divided by 2.75. Right. So what will be this number? Can anybody calculate this for me? Yes. Abdullah? Abdullah, are you there?
कर रहा हूँ सर कर रहा हूँ
शाबाश शाबाश जल्दी करो.
0.17.
कितना आया? 0.17 seconds. ठीक है. Now you can calculate frequency. The frequency will be equal to what? Frequency will be equals to 1 upon time period. 1 upon time period is equals to 1 divided by 0.17. So what will you get?
5.9.
5.9 hertz is the frequency of this wave. Is it clear to everyone?
Yes.
yes sir
So this is basically all about your x-axis. Now, once I talk about y-axis, for y-axis, you must know about another control. That control is your y-gain, right? Y-axis का control क्या होता है? That control is your y-gain. Okay, y-gain, or you can simply say y-gain setting. This basically it is y-axis control. And what does it control? It controls height of the wave, voltage of the wave, yani voltage of the signal, current, magnitude, amplitude, everything. Is it clear to everyone? So, for this purpose, if I have a wave and I just want to draw a wave here, simplified wave, because yes, for example, your if the y gain setting is given to you, if y gain is 5 volts per division. So मेरा बेटा it's quite simple meanings that one division is equals to what? One division is equals to 5 volts. Is this clear to everyone?
Yes.
So now I will draw a wave regardless of this amplitude, regardless of this uh, you know frequency. I will just give you a simple wave, and that wave will be yani just I will try to make you clear that how many divisions do I have and how to handle this all. Okay, now check this wave. This wave is basically, sorry, this wave is having some height. Okay, let me shift this over here. Yeah, that is fine. Now, this wave has a height. How many divisions does it occupy?
Almost two.
Almost two divisions. It means very simple. One division is 5 volt. This division is also 5 volt. So total its amplitude will be 10 volt. So y-axis is simple in calculations. But the same formula will be used that if you want to find out the amplitude of the amplitude of the wave, that is y can setting into peak to peak height of the wave divided by 2. Whatever the wave will be there, you will be able to figure out its amplitude. For example, for example, in simple words, I will change the y gain setting. For example, if y gain setting is 20 volts per division, right? For this one, this wave, then what will I do? I will just consider the two peaks, the distance between these two peaks. One peak is here and the other peak is here. So how many divisions are there?
Four.
Four peaks. Is it clear to everyone? Hello? Four
एक
divisions.
दफा रिपीट
So
कर फिर से
yeah, is it clear to everyone or should I repeat it?
से रिपीट कर देंगे
Okay. I'm saying that basically this is the main formula, master formula, that if you want to calculate the amplitude of any wave, so simple is कि आप क्या करो, you just use this equation. That equation is the amplitude is equal to y gain setting into peak to peak height of the wave divided by 2. So peak to peak height means one peak is here, other peak is here. So this is peak to peak height. What is that? Peak to peak height. And how much is that? This is 4 divisions. Is it clear to everyone?
यस सर
So
Sir, why
here,
to make our lives hard like when we can just simply calculate 5 plus 5 and it's 10 volts?
actually, sometimes the waves are not symmetric and you do not know about their zero position, right? For
So
example,
we
here,
have to calculate average like this.
yeah, this is basically the zero position. Yani, amplitude is what? Amplitude is the height of the wave above or below the main position. So this is amplitude, right?
Yes.
Got it? So amplitude is basically peak to peak height divided by 2. So simply, what will be its amplitude now? It is 20, division and division will be gone. So 20 times 4 divided by 2. What will be the number? 40 volts. Is this clear to everyone? So in this way, we discuss all these oscilloscope problems. But here, yeah, here you will be able to figure out this and this. There will be not a big deal. But these two things, which are basically the uncertainties. Misha, do you have time? Because Misha is blocked ahead for a class. How much time is left? Oh,
Eight
yes, yes,
minutes,
yes.
sir.
8 minutes are left. Misha, you have time, na? So I
Yes,
can
sir.
make you people clear about the uncertainties. Now, there is a question, Annie, in this question, if I need your help, so I believe that you people will help me out. The time-based setting of the CRO is 0.5 milliseconds per centimeter, and Y plate setting or Y gain setting is 2.5 millivolts per centimeter. Use the figure 2.1 to determine the amplitude of the signal. Yes, amplitude of the signal. What will be the amplitude of the signal? I told you, just count the number of divisions between two peaks, right? Isn't it? That's it. And then use that concept of Huygens. How many divisions are there? I mean, small squares. This is a little bit more, complicated question, and it needs more accuracy. How many small squares? One, two, three, four. Okay, let me show you all at once. One, two, three, four, five, six, seven, eight, nine, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. How many small squares are there?
22.
22 small squares. Is this very clear to everyone? It means peak to peak height is 22 small squares, right?
So amplitude will be 11.
11 small squares, but it is not. Actually, in this way, peak to peak height or height between two peaks is 22 small squares. This is not centimeter, but 1 centimeter is equal to how many squares? 1 centimeter is equal
5.
to 5 centimeters. Is it? Check this one out. Any 1 centimeter consists of how many squares? One, two, sorry, wait. One, two, three, four. Is it four? And five. Sorry. It is till this point. Five. So five small squares, right? That is equal to 1 centimeter. Am I right? So
Yes,
can you tell me that what will be the peak to peak height in centimeters?
it will be 2.2 because
Yes.
1 centimeter is 5. So
Yeah,
if we want to find
2.2,
for 11,
22
we'll just do
divided
11
by.
divided by 5.
Yes, very good. Everyone agreed?
So
Yes,
it will
sir.
be 11 divided by 5, right?
None, 22.5. It is peak to peak height. I'm not talking about amplitude. Peak to peak height.
4.4.
2 point?
4.4.
4.4?
Yeah,
Sure. 4.4 centimeters. Yani, this red is going to give you 4.4 centimeter, top to bottom. Is it clear to everyone?
yes.
So, what is Y gain setting? 2.5. So, I will simply say that amplitude is equals to 2.5 millivolt per centimeter. I'm just having a habit of writing centimeter right here just to cancel this all. Into peak to peak height is how much? 4.5
4.4.
centimeter. 4.4 centimeters. Sorry.
4.4.
Sorry. 4.4 centimeters divided by 2. Yes, can anybody help me out to calculate this, please? This centimeter will be gone. And what will you get?
We'll
Okay,
have
hurry. How much?
will be
5.5.
5.5.
5.5.
5.5.
5.5 millivolts. Now, what about frequency? For frequency, you will go by the frequency is 1 upon time period. So, first of all, I will calculate time period and then I will be moving onward. Time period is time base setting into number of divisions, number of divisions divided by number of waves. You got this point? So, by applying this formula, what will I do? I will just go back to the waves, and for that one, I will be counting that. Okay, if the wave is starting from this point, I will count the complete waves, right? If one wave is starting from this point, then uh, one wave is completing at this point. At this point, it is completing 2 point next wave, right? One and a half wave. So it is up to you that either you select the distance between these 2 points, right? This is the ideal one, right? How many small squares are there? Just check this one out. This is the one wave, and one wave is comprises of one, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 centimeters. 19 small squares rather. 19 small squares. So what will be in the centimeters? 19 divided by 5. What will be that?
3.8.
3.8 centimeter. Because 1 centimeter is again 5 small square. 1, 2, 3, 4, and sorry, it is starting from here. 1, 2, 3, 4, 5. So it is again 3.8 centimeter. Now you will say that number of divisions are number of centimeters. And what is time based setting, by the way? 0.5 milliseconds per centimeter into number of divisions are there, 3.8 divisions, and how many waves are completed in that? One. Right? Is it clear to everyone?
Yes.
So just plug in the value, calculate it,
It will
and
be 1.9.
1.9 hertz. Is this clear? So it was having working. That is why you have 3 marks for this. If it is
Sir,
1.99 or something, so you can round it off.
sir, 1.9 to हमारा time, it's the time period, right? Now we'll do 1 over
Oh,
2 to
yes,
get
yes,
the
yes, yes. Sorry,
frequency.
sorry, 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 sorry. Sorry, my bad. That is why. It's the time period. So time period is how much? 1.9 millisecond, right?
Yes.
So what will be the frequency? Frequency will be equals to 1 divided by 1.9 into 10 raised power minus 3. So what will be your number?
Mm. 530.
Yes, 530 hertz. Is this clear to everyone?
Yes, sir.
कोई कंफ्यूजन? मीशा कितना टाइम रह गया?
सिलेबस खत्म हो गया.
एग्जैक्टली बराबर हो गया. Oh, sorry. So I will be main. Okay. आप अगर छोड़ भी दो, इशू नहीं है. Because you people can have this time. 5 minute मुझे और चाहिए. I will explain it. This is basically being recorded, so you can see this recording. Then the topic will be completed. Otherwise, I have to resume the topic again, and it would not be suitable. Okay?
Okay, sir.
कोई प्रॉब्लम तो नहीं है इसमें?
नहीं sir.
ओके. आपकी अगर आगे क्लास कंटिन्यू करना चाह रही हो तो ठीक है. इफ यू वांट टू स्टे इन द क्लास, इट्स योर चॉइस, बट आई विल जस्ट कंप्लीट इट. Yeah, that recording will be shared with you and you will can see that. Okay?
Okay, sir. I'll be leaving. Allah Hafiz.
Okay, thank you, Vinod. Okay, अब आप देखो. Now the question is twisted. The twist of the question is calculate the actual uncertainty f caused by this CRO. Horrible question, because the actual uncertainty by the CRO is in frequency, right? That uncertainty is to be calculated in which quantity? In the quantity of frequency. So beta ji, frequency is calculated from distances, time period. Am I right?
Yes.
Here is basically one interesting thing. I want to add one page and then I will proceed further. Here is a page. Yeah. Okay. That means the actual, you know, I have to do in this way. F plus minus delta F. Is it? This is the task, na? Because here the actual uncertainty, and then you have to write it. State the frequency and actual uncertainty. So this is the answers level. But basically, once I move to this point, the frequency delta F divided by F equals to why there is uncertainty in this. Lulu, can you tell me?
Sorry, what's your question? Actually, the uncertainty.
Yep. I'm saying that why there is an uncertainty in the frequency. What is the main parameter which is causing uncertainty in the frequency?
Sir, I'm not sure.
Okay. Anyone?
Error.
Error? Okay. Error in which variable? Yes, Ali Faisal.
Sir, in the time period, maybe.
Exactly. It is the time. Exactly. Okay. Time. So time is basically the uncertainty in this one. Is this clear? So basically, pata kya hai? When I just told you in this way, your uncertainties will be. So for example, I have discussed one question with you that you want to calculate the uncertainty in the volume, and uncertainty in the volume was basically the uncertainty in the diameter, and due to the uncertainty in the time, sorry, length and all that stuff. ऐसा ही था ना? So first of all, what we have to learn that actually why is this uncertainty in the question? So that uncertainty is due to time period. You got my point? Okay, ji? Clear?
Yes, sir.
So if I say that what is the uncertainty in yani in that value of the value of time period, so I will simply say that that is equals to uncertainty in the time period divided by time period, because there is no power required for to convert from frequency to time period or from time period to frequency. So you can simply say that absolute uncertainty in the time period is basically the least uh, you know value of the the smallest division on this scale. Where is the smallest division on the scale? Yes, what is the smallest division on this scale? It is 1 centimeter. 1 centimeter is represented by small squares. So what is this equal to? This one, can anybody tell me?
0.2 centimeter.
0.2 centimeter. Exactly. So this is basically the uncertainty in my value, yani absolute value, absolute uncertainty in the time period. You got the point? So I can simply say that this is basically 0.2 divided by what was the time period? The time period was 1.9 seconds. Is it? Hmm?
Yes, sir.
Yeah,
Sorry,
1.9
sorry.
milliseconds.
1.9 milliseconds. Okay.
Yes.
Okay, so is it clear to everyone? Mariam, who is with me? Let me check. I have not checked who is with me. Yes, Ali Faisal, Huma, Lulu, Mariam, and Said Abdullah. Is this clear to everyone?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. So 0.2 divided by 1.9 into 10 raised power minus 3, and just plug in the value of frequency. Yes, can anyone please calculate this for me? Hurry up.
105.26.
105.
0.26.
Okay. One of 5.26. Now the change in frequency will be 105.26 into 530. So what will be the number?
56,000.
How much? Wait. Oh, no. We made a mistake here. Sorry. We made a mistake because this 0.2 is in centimeters. So I have to place the value of centimeters in this. So how many centimeters were there in which we have calculated the time period? So what is the total distance from this point to this point? 3.8 centimeter, na? Oh my bad.
Yeah.
Yes, this was the problem. Sorry, really sorry for that misconception. So yeah, I was here. It was 38 centimeter. 38 8, sorry, 3.8 centimeter. Sorry. 3.8 centimeter. Yes, can you now calculate this please for me? Because this was very huge, so this is incorrect value.
0.05.
0.05. आगे नंबर कोई आ रहा है?
26.
Yeah, it is. We will not round it off till to that much to one significant figure array. So this is the fractional uncertainty, or you can say the fractional uncertainty in this delta f is this. So delta f is equals to 0.0526 times frequency. So that will give you 0.0526 times frequency. What was frequency? 530 according to your calculations. What was the actual calculations? 530 or it was rounded off? This one.
Rounded
It
off.
was rounded
What was the
to
actual
two
one?
significant.
526.
Okay, so I will place that value because we will not plug in the rounded off values 526 here. So please calculate the absolute uncertainty here.
28 or 27.7.
7 point
28 if I round it off to two significant.
28 point.
28.
27.68.
Okay, 27.68. Yes. 27.68 hertz. Now I will, this is what you can round it off to 30 hertz, right? Because that we can round it off to the absolute uncertainty is rounded off to one significant figure. We have studied this rule ना Abdullah, हमने ये पढ़ा था ना बेटा, that will be rounded off to one significant figure.
Ji,
So
sir.
is this clear to everyone?
Yes, sir.
So actually there are two steps for this. Here, actual uncertainty will be written as 28 hertz after this all calculation. But for this one, I would write 30 hertz. The reason behind that is I need one significant figure here. I need one significant figure here. And for that purpose, I will write 530 hertz here. So is this clear to everyone?
So it's like for 2 marks and we have to do such long calculation. Isn't there any smaller method, like easier one?
Yes. Actually, you have reached to A levels now. So once you are grown up, you will be awarded little for more work. For example, once you were a kid, mom was giving you a chocolate if you have written ABC completely, isn't it?
सर पर इतनी स्पेस भी उन्होंने नहीं दी कि हम
दी हुई है
कैलकुलेशन करें.
पुत्र. बेसिकली ऐसे कैलकुलेट करना है. मैं तो आपको समझा रहा था. दैट इज व्हाई आई जस्ट extended it step by step. Actually, what you have to do in your exam, you are supposed to do only this step, right? And if you don't want to move more, so instead of this f just plug in the direct value, and this is step and this is step, that will give you the answer. So two step space to hai na.
Okay.
You got it? This is step number 1, this is step number 2. These are basically two exam steps what you need, right? But because I am not in exam, I am in a big exam when I have to, both of us, yani student and teacher, both have exam. The teachers have to satisfy the teacher. Sorry, student has to satisfy the teacher. That is their exam, and student has to satisfy the. Sorry, teacher has to satisfy the student. That is another exam. So both of us are in imtihan from Allah Almighty. Okay.
Sir, sir, the last question where you had to write the uncertainty, we wrote 30 hertz. Like
Mhm.
the last class when we did the question, we wrote the value to one decimal place.
No. Actually, here, if I write this number in this way, 0.3 into 10 raised power 10 raised power 1, then this value will be 53.0 into 10 raised power 1. Yani decimal places must match, but significant figure will only be 1. right? It must be 1 SF. You got the point?
No, like how do like
देखो,
mm,
significant figures will always be 1 in the last answer. Yani this left hand, this plus minus wala. But the decimal place of your certain value will be same as the decimal place of this one. Here there is no decimal place, no decimal place because there is no decimal place. That is why. If I will
Sir,
use
if
any
we are
decimal place,
doing it to one significant figure, then why we have written 530 and not 500?
this is not to write in one significant figure. Who told you this thing?
Okay, so only the uncertainty we have to write
Yes,
in
only
significant.
uncertainty. It is not
Okay.
in one SF, right? Remember this
Okay.
thing. This is the only thing which is in SF, one SF.
And then we have to also make sure that they both, if they both, like
Both must have
either they
same
both should
DPs.
have the decimal point or either they both shouldn't, right?
No, no, both must have same decimal place. Is it clear? But not the SF. Is it clear to you? SF must not be same, but
Okay.
decimal place must be same.
Decimal place must be same, matlab?
मतलब अगर आप यहाँ पे लिख रही हो ना in this way, if your final answer is let's say 4.5, sorry, just a second. If you are going to write, because in one significant figure you cannot write 4.5. In one significant figure, for example, you are going to write 0.04. So how many DPs are there? Two
Two.
decimal place and one. How many significant figures are there? One significant figure. For example, this is having a certain value of 25, something like that. So you will write 25.00. You got my point?
Okay.
Decimal
Yes, I got it.
points, decimal places should be matched. Same. But DP, sorry, the significant figure, it does not have any problem.
Okay.
Is this clear to everyone?
Yes.
Okay. So we will be. I'm just. I'm going to give you the homework from all these remaining questions. I hope that now you people will be able to understand that all. Hopefully, is it?
Like this question was like tested from like two topics, I guess, the waves and this uncertainty.
Actually, the uncertainty is included. When uncertainty is included, no matter the
Yeah.
question is from the waves or current electricity or from whatever that is. You got it?
Yes, I get it.
Okay. So is it clear to everyone?
Yes, sir.
Yes, sir.
Okay. Uncertainties, solutions. Okay. This is theory part. Madhurya. I'm gonna share this with you as well. So see you inshallah in the next class.
Allah Hafiz,
So
sir.
what we'll
Sir,
be
Allah
doing in the
Hafiz.
next class?
Uh, okay, Huma, we will be doing uh, the some of the MCQs based